So we're going to start 7.6, which is going to be about factoring polynomials, which we've kind of been building up to throughout the first half of chapter 7. And so we're kind of finally at the big day. Okay, so we're going to factor with 2 learning targets, one that you can factor and solve polynomials, and then also one that you can use factoring to solve real life problems. Okay, on the next page of chapter 7, section 6, we actually have a little activity here. Should have already gone through that in class, so I'm going to skip ahead all the way to 7.6, page 4. Okay, so if I want to factor these polynomials, as you kind of would have seen inside of the activity, we know that all of these polynomials factor given a certain pattern. So it all starts with identifying the A, B, and C value, because all of these polynomials are going to be in this form. A value is 1, B value is 7, and C value is 10. Okay, so if I look at this, if there's no number multiplied by the, if there's no number next to the x squared, that means the A value is 1. And what we're going to do is called the X method of factoring for us. It may be different. Again, if you're getting help from home, it might be different. And if that works for you, it's totally okay. Where we take any methods here, but this is just the method that we use. So this is going to be what we're going to call just the regular X method. How you do the X method is you just take the A times the C value and the B value is 7. So how does this help us? What does this do? This is going to help me factor because you're going to look for numbers that multiply to the A times C value and add to the B value. Okay, so you're going to look for those combination of numbers. So if you don't know what this combination of numbers is, you're going to start having to list off numbers that multiply to 10. So if I have 10, I can take my calculator off on the side and I can start crunching numbers. The first combination is 1 and 10. 1 and 10 is going to add me to 11. I'm trying to get to 7. So now I'm going to do 2 and 5. 2 and 5 does get me to 7. Positive 2 and positive 5. So this is going to factor into x plus 2 times x plus 5. There's my 2. There's my 5. If I were to box method and multiply this out, x plus 2 times x plus 5 is going to give me x squared plus 7x plus 10. So this is just undoing that multiplication methods that we worked on in the first half of the chapter. Okay. 1b, same thing. A value is 1. And the A value will be 1 for every problem that we do today. So A value 1, B value 7, C value 6. Okay, again, set up the X. All the problems mostly are the same here. A times C is 6, B value is 7. So I'm going to look for numbers that multiply to 6 and add to 7. That combination of numbers is positive 1 and positive 6, not 7 there. That's supposed to be a 6. Okay, 6 times 1 is 6. 6 plus 1 is 7. So what does this factor into? This is going to factor into m plus 1 times m plus 6. And again, if I were to multiply this out, I would get the original and expression of m squared plus 7m plus 6. Okay, now really, honestly, this isn't too difficult of work, although it can get a little bit tricky when you throw negatives in. So here, the process is the same. A value 1, B value -8, and C value 12. All right. And so now what I'm going to do is I'm going to start looking for numbers that multiply to A times C. 1 times 12 is 12. And add to the B value of -8. Now, as I do this, okay, I need to start thinking, what kind of numbers am I going to have that multiply to a positive number but add to a negative number? Well, there's only 2 ways to multiply to a positive and a positive. Obviously, that's not going to work because that's not going to add to a negative. So the other option, though, will work for us, and that is multiplying 2 negatives together. A negative times a negative is a positive. A negative plus a negative is going to be a negative. So here, but the same process is still the same. I need to find numbers that multiply to 12 and add to -8. I just know they're both going to be negative. First combination here is 1 and 12. 1 and 12 is going to give me to 13. That's not going to work. And so now I'm going to try 2 and 6. Now 2 and 6 will work. So it's going to be -2 and -6. So what's my factors? My actual factors are going to be q minus 2 times q minus 6. Okay, 1D. Same thing. A value 1, B value negative 16, C value 15. A times C, 1 times 15. 1 times 15 is 15. B value is negative 16. And again, you're going to look for numbers that multiply to 15 and add to negative 16. Now, again, I'm multiplying to a positive, so I'm adding to a negative, so that's going to give me two negative numbers. And so to find those numbers, you might have to list them off, but guess what? It's the first one, 1 and 15. Negative 1 times negative 15 is positive 15. Negative 1 plus negative 15 is negative 16. So this factors into x minus 1 times x minus 15. Okay, so now what happens when we have to multiply to a negative? Well, everything's the same. You just got to maybe think about it a little bit differently. Okay, still set up A times C. Negative 30 is negative 30. B value of 13. So I'm looking for numbers that multiply to negative 30 and add to 13. But it might actually be more beneficial to, instead of thinking add to 13, which you can, it's just one of those numbers is going to be negative. But since we know I'm multiplying to a negative, anytime you multiply to a negative, that means you're going to have one positive number and one negative number. It might be easier for you to think about what numbers subtract to 13 rather, instead of add. So let's go through it. Here I know that I'm multiplying to 30 and I'm going to subtract to 13. So my first combination is 1 and 30. 1 and 30 would subtract to 29. I'm trying to get to 13. That's not going to be it. Next one would be 2 and 15. Okay, these do subtract to 13. So this is my combination, but now it's a matter of which one is not positive and which one's negative. Well, there's a couple different ways to think of this. First, you could just guess which one's negative and try. The other one would be to, think about if I'm subtracting to a positive, okay, that means the bigger number needs to be positive. So I'm subtracting these two numbers from each other and my result's a positive. That means the bigger of the two needs to be positive. Quite honestly, though, you can just check. I can just go 15 minus 2. Now that's positive 13. That would work. The other option would be 2 minus 15, where the 15 is negative, and that's negative 13. That's not going to work because I'm trying to go to positive 13. So this is going to factor into y plus 15 times y minus 2. Okay, F is going to be the same sort of situation. A value is 1. B value is negative 1. So if it's just minus a variable, the B value, that number would be negative 1. And then C value would be negative 42. I'm going to set up my X, A times C. 1 times negative 42 is negative 42. B value is negative 1. Okay, so again, I'm multiplying to a negative. Since I'm multiplying to a negative, that means I'm going to have one positive and one negative. Since I'm multiplying to a negative, it might be easier to think subtract to negative 1. So we need to figure out what this number combination is. So here I'm going to lay it all out for you right now. If you have no clue what that number is, this is the process you're going to have to work through. And it might be tedious, but it is guaranteed to work. So the first thing I'm going to do is start listing numbers that multiply to 42. Okay, so if you really don't even know those, okay, you might have to take a calculator and go 42 divided by 1. Okay, that's 1 and 42. I know 1 and 42 are going to subtract to 41, and that's not the number I'm going to. So now I'm going to take 42 divided by 2. That's 2 and 21. 2 and 21 are going to subtract to 19. I'm trying to get to 1. 42 divided by 3. 42 divided by 3 is 14. Those numbers are going to subtract to 11, so that's not it. 42 divided by 4 is a decimal, so you can just ignore this. We only want whole number combinations. 42 divided by 5, again, ignore it. You only want whole number combinations. So we divide it by 6, and that is 7. So this is kind of your strategy if you would consider yourself weak with your mathematical facts, which is common and it happens. So this has to be the combination because 7 minus, they subtract to 1. So now it's a matter of, is it -7 or +7? Is it +6 or -6? Well, I'm subtracting to a negative number. So that means the larger of the two values is going to be negative. You can also just honestly guess. If you think it's going to be the 6 is going to be negative, you're going to go 7 minus 6 and get +1. And if that doesn't work, 6 minus 7, -1, the other option will work. So this is going to factor into h plus 6 times h minus 7. Okay, so at this point, what I would suggest doing is pausing the video and going through the monitoring progress problems on page 5. Make sure you're doing that. These problems are ones where you really benefit from the problem solving yourself as opposed to just be given the numbers over and over, because that's all it is just finding those numbers. So pause the video and check it off with me when you're done. Okay, so I'm assuming that you've already paused the video. You're looking for feedback on how you did on all of these. Okay, so here, and I'll go through them pretty quick since you have the problems completed already. Okay, A value, B value, C value. Okay, A value here is 1. We're looking for A times C is -4, and B value is -3. I'm multiplying to a negative, so I'm going to think subtraction instead of addition. Most people get stuck on 2 and 2, but you do have the combination of 4 and 1. Okay, since one's positive, or since I'm multiplying to a negative, one's positive and one's negative, we know that I'm subtracting to a negative number, so that means a larger value is negative. So our factors are going to be B minus 4 times B plus 1. Okay, number 2. I'm multiplying to A times C. A times C, 1 times 5 is 5. B value is 6. Okay, this one I'm multiplying and adding to all positives, so that means all the numbers are positive. It's going to be 5 and 1. So this is going to factor into C plus 5 times C plus 1. Okay, 3. Okay, A times C here is -18 and B is +7. I'm multiplying to a negative, so that means I'm going to think what number subtract to 18. And I don't know this one off the top of my head. So what we're going to do is multiply to 18, 1 and 18. That's the first one. 1 and 18 are going to subtract to 17. I'm trying to get to 7. So I divide 18 by 2 and I get 9. These do subtract. So is 9 minus 2 7 or is 2 minus 9 7? Well, +9 minus 2 is going to be 7. So that's the combination. Again, I'm subtracting to a positive number, so the larger of the two is going to be positive. So this is going to be x plus 9 times x minus 2. Okay, same thing. I'm multiplying to a positive 20 here and adding to a negative. So I'm multiplying to a positive number. So instead of subtract, I'm going to think add. And I got to figure out, well, I'm multiplying to a positive and adding to a negative. That means I'm going to have 2 negative numbers. And what combination is going to get me to 9? 1 and 20, no. 2 and 10, no. 3, it doesn't divide by 3 evenly. 4, no, it does. And 4 and 5 will get you to 9. So this will be y minus 4 times y minus 9. Okay, monitoring progress 5. So here again, we're multiplying to positives and adding to positives, so everything's positive. We're trying to multiply to 32 and add to 12. Both numbers are going to be positive in this situation. So you might have to start listing combinations that multiply to 32. Okay, so if you don't know what those are, literally list them, use your calculator one at a time. 1 and 32, that does not work. 2 and 16, that also doesn't. It doesn't divide by 3, but it does divide by 4. So it's going to be +4 and +8. So this factors into t plus 4 times t plus 8. Okay, number 6. Here I'm multiplying to a positive. So I'm going to think add to -14. Okay, so you might have to start taking your calculator, especially with 45, use those problem solving skills, just go one at a time if you need to. Ultimately, you're going to come down to -9 and -5. Those multiply to 45, but yet they add to -14. So my answer is going to be g minus 9 times g minus 5. Okay, and that's how you factor when the a value is 1. Okay, so now that we have factoring down, let's put that to use. Okay, so in the previous section, we talked quite a bit about the zero product property. If I take one number and multiply it by another number and its answer is 0, then that means one of those two numbers is 0. If a times b equals 0, then either a is 0 or b is 0. So when it's already factored, we worked on problems like this, it's really easy. If I have x plus 2 times x minus 9 and my answer is 0, that means x plus 2 is equal to 0 or x minus 9 is equal to 0. Knowing that, what I can do is I can solve for x, each of these respectively, and then I'm going to have two solutions. I'm going to subtract 2 and get x is -2, and I'm going to add 9 to get x is 9, and then I just have two solutions. So it's really nice when the problems are already factored and set equal to 0. On 2b, that's not the case. First off, it's not set equal to 0, and second, it's not factored. So we're going to try to do both of those. First things first, set it equal to 0. It's currently set equal to -8, so I'm going to try to undo -8 by adding 8. Okay, because -8 plus 8 is 0, so now I have x squared minus 9x plus 8 equals 0. Okay, so now that it's set equal to 0, I can actually factor this because we just worked on factoring, so we can put it in a form that's similar to this, set both of them equal to 0, ta-da, we're going to be done. So we're looking for numbers here on the side that multiply to 8 and add to -9. Okay, I'm multiplying to a positive. Since I'm multiplying to a positive, I am thinking add, and this one's going to be pretty straightforward. It's going to be -8 and -1. So this means that x minus 8 times x minus 1 is equal to 0. Zero product property tells me that either x minus 8 equals 0 or x minus 1 equals 0. Okay, so again, set equal to 0, factor, set factor is equal to 0, 3 steps. Okay, take a moment, pause the video, and try 7 and 8 on your own. Check it with me when you're done. Okay, so I'm assuming that you've already paused the video. You're looking to see how you did. Okay, 7 should be a review problem, should be pretty easy. They're already set equal to 0. So you just solve each of those problems. Set equal to 0. Okay, this one here, I would just plus 1. So x is 1, and here I would minus 4. And that's equal to -4. Okay, on 8, though, it's equal to 16. And I need it equal to 0. So I need to undo it being equal to positive 16, and I can do that by minusing 16 from both sides. Okay, and so now I'm going to factor a times c. A times c is -16, and b is +6. So I'm looking for numbers here, since I'm multiplying to a negative, that multiply to 16, but subtract to 6. You might have to spend a little time off on the side finding these numbers, but it is ultimately +8 and -2. Once you have that, you can factor it into c plus 8 times c minus 2. And then set each of those factors equal to 0. C plus 8 equals 0. C minus 2 equals 0. And this is using, again, the zero product property. One number, c plus 8, times the second number, c minus 2. my result is 0, that means one of them is 0. So here, I minus 8 from both sides, C equals -8, plus 2 from both sides. C is equal to 2. Okay. So now all we have left to do is put this to use with some real situations. Okay. A farmer plants a rectangular pumpkin patch in the northeast corner of the square parking lot or field. Okay, so this is our pumpkin patch. I just outlined it. The area of the pumpkin patch is going to be 600 meters squared. So this is going to be 600 meters squared. Okay, and we want to find the area of the entire plot. So I basically need to find this length and width because I don't know what these are. Right, these are question marks, but I know this number times this number is 600. Okay, so what do we need to do? So I know that if I can kind of port this is length S, and this is also length S. Okay, so if this is the total length here, this distance is going to be the total length minus 40. This distance here is going to be the total length, and this here would be the total length minus this 30. So that's going to be the critical point because I know that the whole thing, the area is equal to length times width, and we're talking about this little blue area. Well, how do I find this little blue area? What I have to do is I have to take this total length, and this distance is going to be the total length minus 30. Okay, so the length here is going to be S minus 30. Okay, but then on the other side here, the width is going to be similar. I have to take the total length here, and I got a minus 40 from it to find this distance. So S minus 40. So I have an equation to satisfy this whole area formula. First off, the area is 600. And the length is S minus 30. And the width is S minus 40. Okay. So what appears as though it might be nice, but it's not going to work the way that we want it to be, is that is, it looks like it's factored already because it is S minus 30 times S minus 40. The only issue is that, it's not set equal to 0. So since it's not set equal to 0, we actually have to multiply this out minus the 600 and then refactor. So off on the side, I'm going to box method this here. Okay, so we need to multiply S minus 30 and S minus 40. Okay, a little bit of algebra off on the side. This is going to be S squared. This is going to be minus 30S. This is going to be minus 40S. And this is going to be positive 1200. So I have 600 is equal to S squared. And then these parts combine together into negative 70S plus 1200. So now this problem's set up in a way, so now I can minus 600, and because then it's going to be set equal to 0. So that's exactly what I need to do. I need a minus 600 from both sides to get 0 is equal to S squared minus 70S plus 600. Okay, since it's set equal to 0, I can now factor it. So I'm going to be looking for numbers here off on the side that multiply to 600 and add to negative 70. So I'm going to be looking for two negative numbers. Okay, you might have to do a little bit of work here. You might have to take 600 and start finding all these factors. And it could take a little while. 1 and 600, 2 and 300, 3 and 200, 4 and 150, I believe. Yeah, 4 and 150. Okay, 5 and, I'm having a brain fart doing too much mental math, 120. But then eventually you are just going to be continuing on down this road. And eventually you're going to get to 10 and 60. Okay, so it might take a little bit of time if you don't know this right off the bat, but 10 and 60 is going to be your combination. They're both negative because I'm multiplying to a positive by adding to a negative. So this factors into 0 is equal to S minus 60 times S minus 10. So I can set each of these factors equal to 0. And solve. S is 60. S is 10. So these are my answers, but which one is actually my answer? Because I got 2. Well, we have to think about it. If I plug in the side length, if I'm saying this whole length is 10, that doesn't really make sense because we know part of this is already 30. You know, because we can't have the total side length be less than what that chunk is already. So it's going to have to be 60 meters and not the other one. So algebraically 10 is a solution, but given the context of the problem, 10 is not. Okay, take a moment, pause the video, and when you're done, check it off with me. Okay, so it's going to be the exact same problem. The only difference is that the area of the pumpkin patch is now 200. So our same problem is going to hold, but instead of 600, the area is 200. Okay. Luckily, off on the side, we've already multiplied this out. So that's going to save us a little bit of time. So we know 200 is going to be equal to S squared minus 70S plus 1200. Okay, and then we're going to minus 200 from both sides. Okay, so then now what we're going to do is we're going to be looking for numbers that now multiply to 1000, but add to negative 70. And again, this might take you a little bit of time because the combination is actually going to be negative 20 and positive 50 and negative 50. Okay, so again, it might not hurt to think, you know, it's kind of scale with the numbers scaled down a little bit, but you know, negative 20 times negative 50 is 1000. These two added together is negative 70. So here, what I'm going to get is S minus 20 times S minus 50, which means S minus 20 equals 0 and S minus 50 equals 0. Solve each of those by adding 20. S is 20 and plussing 50. S is equal to 50. Now, again, we have to figure out which one's our answer. It's got to be 50 because us saying that the side length of the whole patch is 20 doesn't make sense when we already know one part of it is 30. This whole distance can't be less than that part distance. It just doesn't compute.